Good afternoon, everyone. I hope you all had a very good lunch. So after lunch, I think it's a difficult job for us to keep awake. I'll try my level best to make it interactive if it's possible. So till now, we have, during the day, talked about different applications, right? We have talked about LLMs, we've talked about SLMs, we've talked about AI use cases, we have talked about services that can be rolled out to the citizens, right? But what in the next 10 minutes we'll talk about is the underlying network, right, on which these applications will run. And that network will determine how these applications are actually behaving in the network, how they are performing in the network, right? So it is very, very critical piece of it, right? Currently, most of the networks that we have are not designed to actually take care of AI workloads, right? It's unfortunate, but it's not there actually to take care of the AI workloads. So where are we today in India, right? We are actually moving away from the basic digitization to intelligent governance, right? And if you see on the right-hand side, there are certain initiatives or the domain areas which the government of India is actually focusing, where they believe that AI can actually play a very, very critical role, and they want to develop those use cases and have very big ambitions around those, right? But one thing that is important that you must notice is all these AI use cases, right, all these domains are actually orbiting around one central theme, and that is the national AI infrastructure. So that becomes a very, very critical piece, right? So whether it's your application, whether it's your AI analytics piece or it's an AI application, right? Ultimately, how they perform will depend upon the underlying network, right? So AI actually is at a stage where it should not just be considered as an application, but as a critical national infrastructure. And it must be treated similarly in the same fashion when we discuss about the budgets, when we discussed about the architectures, and also on the governance framework. So where is the gap, right? So if we see the traditional data centers that we used to build, right, on the left-hand side of the net, on the left-hand side of the screen, right, is the traditional data center, right? And those were built to handle hundreds of GPUs, right? And the traffic was very, very less, and the bandwidth was very, very minimal, right? It was minimal bandwidth, right? And they were actually working well for this kind of an environment. Now, if we bring in the GPUs or the AI workloads on the same infrastructure, right? So the fundamental difference will be there will be a lot of GPUs. If there is a training model that is deployed, there will be a lot of GPUs. And what will essentially happen is it will create a congestion, right, in the network. And because of that congestion, what will happen is your expensive GPU resources on which you have spent crores of rupees, right, they will sit idle. And why they are sitting idle? Just because the underlying network is not able to give the data at a pace at which the GPUs were expecting, right? So we have to relook at how do we actually build the data centers for the AI workloads. So if we really have to do this transformation, we first have to transform the underlying infrastructure. That is very, very critical. So from an architecture point of view, right, what is the difference? Why we are saying that AI is different and the traditional data centers are different, right? So there are 4 dimensions to it, right? One is the traffic flow, the scale, the performance, and the network profile, right? So the traffic flow in traditional data center was north-south, from the client to the server. Whereas one big difference in the AI space is the traffic goes east-west between the GPUs to GPUs, or the AI models to AI models, right? So that is a fundamental difference. Traditional networks were designed for north-south. There is a lot of east-west traffic going in AI. Second is the scale. In the scale, there are few hundreds of GPUs to hundreds and thousands of GPUs, depending upon how large your model is, right? And third is performance, right? So traditional networks were designed for a best effort performance, whereas the AI networks have to be built for your deterministic low latency performance. And just imagine that if there is an AI service that Government of India has rolled out, right, you would always want that the service should be deterministic every time. It should not happen that at one point it is behaving certain way, at the other point it is behaving in a different manner, right? So it has to be deterministic. So if you see all these 4 dimensions, the requirement of AI workloads is actually completely inverse. So if we think that to run an AI workload, I just need to upgrade my network, I think we need to rethink it, right? It is not just an upgrade, but it's an architectural rethink. And Arista has actually worked for the past 1 decade to rethink that architecture. And we have been working with a lot of governments as well as the hyperscalers and the AI scalers to build those kind of an architectures. So what are the foundations of this new paradigm shift that we are seeing, right? What is the first is the underlying physical infrastructure. How do we build that, right? So the way AI networks have to be built from is using the leaf and spine architecture, right? What happens and what's the benefit of using this kind of an approach? All your GPUs, if you see, right? These are the GPUs at the bottom. All the GPUs are just 1 hop away from the other GPUs, right? By taking this approach, what happens is you are bringing in a predictability into the network. You are actually ensuring that if a traffic goes from GPU 1 to GPU 2, it always gets the same latency, or it is just 1 hop away, right? That is one big difference that we get. So it is equidistant scaling. Second is modular expansion, right? So this approach allows you to build a network right from a small data center wherein you are running a small, you have a small AI requirement, you can just have a couple of switches, to a large data center which have hundreds and thousands of GPUs that need to be connected. Just to give you a perspective, let's say if there's a state government who is adopting AI for the first time, right, we can actually use the same leaf spine architecture with few number of switches and build that infrastructure for them. And in the same fashion, as we discussed during the day, the GST initiative and UIDI, right? There are billions of transactions that happen on a daily basis, right? Which require hundreds of thousands of GPUs to be connected. So even that scale can be met with the leaf and spine architecture that Arista actually developed. So it meets all your small, medium, and large infrastructure requirements can be met with this particular approach, right? And oh, sorry. The next innovation is, and I think when we are actually building our requirements at the time of building the RFPs for the AI infrastructure, this is one thing that actually gets ignored a lot when, that is the performance, right? So just to give you an example, right? If you are building an AI training workload, right? And if even there is one single packet drop that happens in the network, it can actually degrade your performance of the network, right? Your GPUs can actually get stalled and will ask to do a retransmission, right? And because of that, what happens is, let's say you build a cluster of 100 GPUs, right? You have paid for that, it is there, it is connected, but they are not performing to the full capacity. And they are just behaving if there are 20 GPUs in the network. And why is that? It's just because of a single network event that was one single packet drop. So a lossless fabric is very, very important when you build a network. It has to be taken into account from day one. It has to be a lossless fabric. Otherwise, your application will not work, not perform the way you expect them to perform. So how Arista is solving this problem? So Arista is solving this by its technologies like virtual output queuing, then RDMA over Ethernet, and also large buffers. So once we build these networks, how do we manage this? So Arista is a big proponent that we are using AI to manage the AI network, right? So what we do is, if in the traditional networks, right, how a network engineer works is, if there is a failure in the network, right, he opens up a ticket, he calls somebody who works on the problem and then resolves it, right? But with Arista's AI approach, what we do is, our Cloud Vision and EOS are continuously observing the network, right? And with NetDL, we are analyzing the state of the network continuously. And if there is an action that needs to be taken, that can be taken automatically using our Ask Ava. So Ava is our machine learning platform which actually leverages machine learning and is able to predict if there is any failure that is expected to happen in the network, and also can take a corrective action. It can suggest an action or automatically take a corrective action if required. One important aspect is digital sovereignty. So when we talk about digital sovereignty, right, and we always talk about data retention or data retention in the country, but I think it is much, much beyond that. It is also related to the technology openness, right? So if we build, there are two approaches to build a network. If you see on the left-hand side, if we build the network infrastructure using a proprietary technology, right? So with that, what happens is, if in future you have to do an upgrade, you are tied up to the same technology. You have to upgrade your GPUs, your underlying networks, or AI cluster, AI chips from the same vendor ecosystem. But with Arista's approach, we build the networks using Open Ethernet, which is an open standard, and which is also UEC compliant, right? And that allows you to get the digital sovereignty. So any NIC, any GPU can work on the Arista fabric. So that gives you a digital sovereignty and a freedom to pick and choose the best of breed technologies available in the network. So this is my final slide, just to want to summarize, right? So it is a 3-layer blueprint, right? At the bottom is the network, right? And then the second layer is the compute on which your GPUs reside. And on the top are the applications, right? Like your all the UIDI or other applications that run. And they are governed by the two principles. One is your openness, right? And second is resiliency and availability. Yeah. So with that, we just want to close that Arista is there to work with you, to be your partner in the AI journey, and can be a trusted partner to build a robust network infrastructure for your AI ambitions. Thank you very much.